Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that find the Laplace transform of the following. Solution. We'll start with the first one. The function f of t is equal to t. So in this one, in this first two, I'm going to use the first principle method of solving Laplace transform. In this one, I'm going to use the standard values from the table, from the Laplace transform table. It is usually important that you memorize the Laplace transform table before you start Laplace transform. It makes things easier for you. You can Google on the table, you will see the table that gives the Laplace transform of several functions of t in terms of s. So this one, let's use the first principle here. So the Laplace transform, this L of t, is given by, from the first principle, the integral from infinity to 0 exponential negative st. Then you write the function t, then the t. So all this function is constant except this t. Any function you want to integrate, you put it into this. If I want to integrate exponential t now, instead of this t here, I'll write exponential t here. So that's this, but this integral of infinity to 0 exponential negative st, the t, they are all constant. So now, in this one, we have to use integration by part to solve this integral. In one of my previous videos, I taught on how to evaluate integrals using integration by part. The link of the video is down in the description below. You can check it out for a better understanding of this integration by parts that we're going to do now. So, u here is what? U is t, and the v is what? Exponential minus st the t. So now we find the derivative of this. The u is equal to what? 1. The t, because it will be du dt is equal to 1. And if you cross multiply, the u is equal to t. Then you find the integral of both sides here to find v. Integral of this is what? Find the derivative of this minus s. Then it will be exponential minus st is minus, and divide it. This is v. So now, this integral now, the integral from infinity to 0 exponential minus st t dt is equal to uv. Using integration by part, uv is what? Is minus t exponential minus st over s, then minus integral of v du. What's v? This is v, then this is du. So it's negative exponential minus st over s du. V du. So now we are substituting in terms of t. So this du now becomes the t. We are substituting v du here, integral of v du. So this is v, and the u is what? The t. So now we integrate this. And remember that the integral is from 0 to infinity. 0 to infinity. Minus t exponential minus st over s. Then this negative becomes positive. Now we can factor out 1 over s. This becomes what? The same negative. You know the derivative of this is minus s, so it will be negative exponential minus st over s. So now we can substitute from 0 to infinity. So now we can substitute the two limits in the full integral. But first, let me open the bracket. So it's minus t exponential minus st over s. This becomes negative now. Exponential minus st over s squared. 0 to infinity. So if we substitute infinity here now, exponential minus st is the same thing as 1 over exponential st. This exponential negative st is the same thing as 1 over exponential st. So 1 over exponential st, if you substitute infinity as t now, it will be 1 over infinity. 1 over infinity is what is 0. So 0, and here t will be infinity. So 0 times infinity is 0. So it will be 0, and then negative is 0. Then it will be negative 0 over s, which is 0. Here will be 0. Here also will be 1 over infinity, which is 0. 0 over s squared is 0. So therefore, if we substitute infinity here, this whole expression will be 0. So it will become 0 minus. So it will be, substitute 0 here. This becomes what? Exponential 0. Exponential 0 is 1. Here is also 0. So everything here will be 0. Then, remaining this term, it will be exponential 0. Exponential 0 is 1. So it will be negative 1 over s squared. So this becomes what? Negative times negative is 1 over s squared. So the Laplace transform of t is 1 over s squared, where s is greater than 0, because we don't want it to be infinity when it becomes 1 over 0, which is infinity. So s is greater than 0 here. So this is the Laplace transform of t. So now, let's solve the second one, which is ft is equal to exponential t. So the Laplace transform of exponential t is equal to integral from infinity to 0 exponential minus st exponential t dt. So this becomes, so since these two exponent functions are multiplying each other, we can add their powers. So it becomes exponent minus st plus t, which is the same thing as t minus st dt. So now we are going to express this power in a formula that is similar to this minus st. We are going to express in this form. So we are going to rearrange this and factorize it. So it becomes what? Exponential. Now it will be negative s minus 1 t dt. Now if you open this bracket, you see that this is negative s. It will be negative st. If you open this bracket from both sides, it will be negative st. This is negative st. Then this is what? Negative times 1 is positive. Then t times 1 is what is t. So it's t minus st. This is the same thing as this. And we have expressed it in this form. So you can see it. So now we can integrate this. It becomes what? This becomes negative s minus 1. That is the derivative. Then we divide this whole function by it. So it becomes what? To integrate this function, we differentiate the power, and then we divide the whole function by that derivative. So this becomes what? Exponential minus s minus 1 t over what? Minus s minus 1. 0 to infinity. So now we can substitute this infinity and 0. We substitute infinity here, just like before, it will be 0, because to be 1 over exponential infinity, which is 1 over infinity, which is 0. Then 0 divided by this is 0. So it's 0 minus, when we substitute 0 here becomes exponential 0, which is 1. So we'll substitute this. Then this becomes, if you substitute x exponential 0 is what is 1. Is 1 over negative s minus 1. Then now, if you open the bracket, this becomes 1 over s minus 1. Usually, in Laplace transform, we don't want the denominator, what is down here, to be 0. That is why in this case, we'll say where s is greater than 1. Because if s is 1 here, it will be 1 minus 1, which is 0. Because if it's 0, the equation, the whole expression will be undefined. If s is 1 here, it will be 1 over 0, which is undefined, or infinity. Here also, it will be, if it's 0, if s is 0, it will be 1 over 0, which is undefined, or infinity. So we don't want that. So the Laplace transform of exponential t is 1 over s minus 1. So now, the final one. 5 exponential 2t minus 4t cubed. So now, the Laplace transform, this one, we are going to just use the expressions, the standard values of Laplace transform given in tables. So the Laplace transform of this 5 exponential 2t minus 4t cubed is equals to the Laplace transform of 5 exponential 2t minus the Laplace transform of 4t cubed. So now the Laplace transform of exponential 2t is given from tables that is equals to 1 over s minus what is here, which is minus 2. If it's minus 2 here, it will be s minus minus 2, which is plus 2. So it will be s plus 2. But since it's 2 here, it will be 1 over s minus 2. Then here, the Laplace transform of t cubed is given as 3 factorial over what? Over s n plus 1. So it's 3 factorial over sn plus 1. And n is 3, so it's 3 plus 1, which is 4. So s is power 4. So this becomes what? 5 over s minus 2 minus, so 4 times 3 factorial is what? Is 4 factorial. 4 times 3 factorial is 4 factorial. So it's 4 factorial over s raised to the power 4. So this is the Laplace transform of this function. So we have successfully found the Laplace transform of all these functions. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.